All right. So here's the first part that you really need to know. Everything else you already know how to do, but I'll do those examples here in a minute. But I'll get the thing out of the way that you need to know right off the bat. First of all, what is the area of a triangle formula? 1/2 base times height. Very good. Well, that's all great if you know the height of a triangle. Okay? If you don't know the height, you need a different formula. So that's where we get this formula, 1/2 a times b times the sine of theta. So this should be on your formula sheet. Okay? Huh? Well, memorize all the formulas then. All right, so what that means is this. Anytime you have a triangle and you have A and B, theta has to be in between those two. Has to be. So if I have a triangle and I say theta's here and I have A and B over here, I can't do anything because theta is not in between the two sides. So the angle you are using has to be the angle between the two sides you're using. Does everybody understand that? Excellent. Let's move on, shall we? All right, now also on your what? Also on your formula sheet, you should have your Pythagorean identities and your reciprocal identities, meaning sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent, right? You should have those. So sine equals 1 over the cosecant, cosecant equals 1 over the sine. So those are your reciprocal identities. You should have those on your formula sheet. You're going to need them. And you should also have the Pythagorean identities, if you remember what those were. So sine squared of theta plus cosine squared of theta equals 1. You also have the tangent squared of theta plus 1 equals the secant squared of theta. And I think the last one is 1 plus the cotangent. Yeah, 1 plus cotangent squared of theta equals the cosecant squared of theta. All right, so those should be on there as well. You need those today for the harder problems. Now, everything other than the area of a triangle, you have already done in all the other lessons. So if you want to, you can ignore me, open up your book, and start working on your homework. Or let me review with you. I would suggest you listen and go through the review problems with me. Okay? All right. I'll do that last. All right, let's just go through the same things in the book. Okay? So let's go through the first set of problems. We'll do 6A. 6A is 175 degrees, and it's asking for the reference angle. So 175 degrees goes all the way over here. Can anybody tell me what the reference angle is? Closest distance to the x-axis. 5 degrees. 5 degrees is your reference angle. 6B. Don't confuse this with a coterminal. And on the test, you have to know both. Okay? So 6B is 310 degrees. 270 and 40 more. That's 310 degrees. What is my reference? $50 degrees. I like different colors. This is great. 6C. Is that big enough, guys? 6C is 730 degrees. Where's 730 degrees? 360, 720, There's 730 degrees. What is my reference? And all right, let's do some more. Okay, let's do, we're going to do number 9 because you don't have to do this one. Number 9, A is 7 pi over 10. So here's where the lesson gets a little bit harder, but you just got to think about it. So if you have your angle in degrees, then your answer needs to be in degrees for references. If your problem is in terms of pi, your answer needs to be in terms of pi. If your problem is in terms of radians, then your answer needs to be in terms of radians. We're going to do all three. So we just done degrees, now we're doing pi. This is 10 pi over 10, isn't it? This would be 5 pi over 10, wouldn't it? You with me? Where's 7 pi over 10? About right here somewhere. Okay, 7 pi over 10. So, what's left? Three pi over 10. Because this is 7 pi over 10. 3 pi over 10 added to that would get me to 10 pi over 10, wouldn't it? Okay, just making you think. Okay, let's do 9b. Is it big enough on the screen? Okay, all right. All right. 9b is going to be 9 pi over 8. So again, you need to figure out where that's at. 8 pi over 8 is at pi. So, what is this? This is 8 pi over 8. 9 pi over 8 goes to right here, so what is the reference? Pi over 8, thank you. Now let's keep going. What you need to be careful of, 9c, 10 pi over 3. What you need to be careful of is this. Listen. Is where the halfway points are. Are you further than the halfway point? Which side of the 90 and 270 line are you on, the y-axis? So pi over 8, I think that was obvious. So on the first one here, on 9a, I specifically showed you where 5 pi over 10 was. That's pi over 2. That was half of what they gave you. Okay? So you got to always be aware of where that halfway point is. All right, so 9c, 10 pi over 3, where are we? What is 10 pi over 3 as a mixed number? Mixed number. 3 1/3, right? Which, that's 3 pi, and pi over 3 is what that is. So where's 3 pi? 2, 3, and 1/3 pi over 3. So what is this? Pi over 3. That's your reference. It's always positive. It's always less than 90 degrees. Anybody totally lost yet? Or are y'all good? Getting smarter? Anybody feel like they're getting smarter? No? Really? You should feel real smart. Can I go on? Okay. All right, so now let's do the radians. Let's do 12A. So this is 2.3 pi. Again, it's in terms of pi. So where do you think we are? Which quadrant do you think we're going to end up in?
Third.
Now this is a coefficient on pi. Where's 2 pi at? 2 pi. Now I have to go another 0.3 pi. Okay, again, where is this halfway point? 0.5 pi, wouldn't it be? Because all the way around is pi, so 0.5 pi is right here. So 0.3 pi must be over here somewhere. So what is my reference? 0.3 pi. It's not meant to be difficult. Just use your brain. All right, 12b. 12b is 2.3. Now we're in radian measurement without the pi. So let me refresh your memory. This is 3.14. This is 1.57. Remember? Huh? What'd you say? Okay. So 2.3 is going to be over here somewhere. So again, how do I find the reference? Subtract. So 3.14 minus the 2.3. 1.84. That's not right. 0.84. I love erasers. 0.84. Never made a mistake. Never happened. So 0.84 would be your reference. All right, okay, you got everything for... Now remember, references aren't negative. Just a heads up. Next. Woo. Next thing on our list is finding exact values. This is just your unit circle. So I'm just going to do number 26. You should know what this is. Everybody tell me what the cosine of 4 pi over 3 is. These are all unit circle values. Well, where are we? 60 is pi over 3. 120 is 2 pi over 3. 180 is 3 pi over 3. 4 pi over 3. Long leg, short leg. What's the cosine? I wish I had big X up here. I could just slam it. Just zap your seat or something.
More people watching this video are going to hear your...
Nobody's going to watch my videos. Yeah, I am, yeah. I'll just use a different name. My name is Mr. Boswell.
Oh my God.
Mr. Orr. Take your pick. All right. All right, let's move on. That's all that section of problems was. Now, which quadrant am I in? Okay, so quadrant, question mark. Here we are. This is number 38. Pay attention. You need this. Tangent of theta is negative, and the sine of theta is also negative. So, where am I? Tangent is y over x. It has to be negative, which means one of them is negative, y or x, not both of them. The sine is the y value. It's negative. So if it's negative, then that's negative and x is positive. Oh my gosh. Both are positive in the first quadrant. X is negative in the second quadrant. They're both negative in the third quadrant. And in the fourth quadrant, y is negative and x is positive. You are in the fourth quadrant, people. Sorry.
That's offensive.
I didn't record it. Beep. Okay. I'm going to save the hardest part for last, okay? So find the values of the trigonometric functions from theta from the information given. All right, so let's do number 50. I haven't done this one yet. Whoops. 50. So it says the cotangent of theta is negative 8/9. And it says cosine is positive. All right. Cotangent is the same thing as what with x's and y's? In terms of x and y, what is cotangent? X over y, isn't it? And the cosine is x. It's positive. All right? You'll see why I'm doing this in a second. So if x is positive and the cotangent is negative here, that must mean y is negative, right? Okay. Which means this negative really needs to be on the 9. Now, if that's the case, what quadrant are we in? X is positive.
It's either in the first or fourth.
If y is negative, you're in the 4th. So this is what you have. You're all the way around here, and you have this right triangle. The cotangent, x is positive, y is negative. And this is what you have. X is 8, and y is negative 9. And now use the Pythagorean Theorem to figure out your hypotenuse. Everybody do that, please. How does this 145 break down? Or doesn't it? It's 5 and 29. Those are both prime. Hmm? 3 won't go into it. I'm asking. I don't know. I haven't done it yet. Did anybody figure out one that goes into it? Otherwise, it's just you're gonna have to use the square root of 145. For right now, for the sake of time, we'll use the square root of 145. Okay, that's your hypotenuse. And so we're not gonna finish this, but this is asking for all the other trig functions: sine of theta, cosecant of theta, and then the cosine of theta, and the secant of theta, and then the tangent of theta, which would then be negative 9/8. Okay, so do you remember how to do all that, the rest of it? This is how you set it up, though, to solve for all the pieces. Can we move on?
It would be 8 negative 9.
Cotangent's already negative 8/9 at the top. So
Oh.
tangent's going to be negative 9/8.
So that negative stays.
It's just on it. It's just saying it's negative. Isn't the tangent negative in the 4th quadrant?
I mean,
Okay. All right, so now let's work on the hard problem here. We ready? All right, so you're going to need... Oh, crap.
I'm gonna need crap.
Now,
really?
there we go.
Right? This is the 3rd freaking time today. Okay, now take this
It's just water.
It's all over me.
Well, there's a reason it's all over you.
It's all over his calculator. Oh.
There's napkins in the cabinet. Can we go on, please?
Yeah, okay.
You ready? You need to know how to do this. You okay? Oops. Okay. We've done this as well, and you didn't like it before, and you're not going to like it again. So I'm going to give you some specific steps. So number 42. Write the cotangent in terms of the sine, and you are in the 2nd quadrant. Step 1. Use first trig function for Pythagorean identities. That's step 1. So you go all the way to the top of your notes for those Pythagorean identities, and you identify which Pythagorean identity has the cotangent in it, please. Which one? Tell me what it is.
1 plus cotangent squared theta cosecant squared theta.
Okay? That's step 1. Step 2. Solve for the first trig function, meaning, in this case, cotangent of theta. So everybody needs to solve that Pythagorean identity for the cotangent. I was wondering what the problem was. So what we're going to do now is the 1 needs to be moved across. So this is going to be the cotangent squared of theta equals cosecant squared of theta minus 1. You with me? Now you take the square root of both sides. And you get the cotangent of theta equals the cosecant squared of theta minus 1, and it's the square root. When you take the square root, that's plus and minus, positive and negative. You can't see that, can you? She's so much better. You can't take the square of parts. You're taking the square root of that whole thing. You can't separate plus and minus signs. What? Because that's the only thing under the radical. Okay, what's the square root of 9? What's the square root of 9 plus 4? Square root of 13 is not the same thing as 3 plus 2, which is what you wanted to do, right? Not the same thing. You can't take the square root of parts. All right. So what's the plus and minus for? You are in the, what do we say, the second quadrant? So it is all based off of the first trig function again, not what you're changing it to. So what is the cotangent in the second quadrant? Positive or negative? It's negative. So this is going to be negative, all right? Negative when we're done. Doesn't matter that the cosecant is the sine reciprocal of the sine, and that's positive in the second quadrant. That doesn't matter. It's all based on the cotangent, the first trig function, until you get to step 3. Step 3. Step 3. Manipulate to get second function. In this case, we wanted it to be the sine. So we got to change the cosecant into the sine. How do you do that? 1 over sine is the cosecant, isn't it? All right, so let's rewrite this. And we get, I'm just going to write the right side, negative square root of 1 over the sine squared of theta. It's squared because the cosecant's squared. Minus 1. You can say, hey, I'm done, I just did it. No, you're not done. You can't leave fractions inside of your radicals. You can't leave radicals in your denominator. You can't leave fractions inside of fractions. Technically, you're done, but you can't leave it like this. If it can be reduced, you reduce it. So now you do the math behind all of this. So how do we do this? We combine the fractions. So, since I have all this digital space, 1 over sine squared of theta, and 1 is the same thing as the denominator over itself. And we want the same denominator. Sine squared over sine squared. And now you combine those. I'll write a little bit bigger. 1 minus the sine squared of theta over the sine squared of theta. Almost done. Now I can take the square root of the denominator. I can split the radical under the top and the bottom, can't I? So what's the square root of sine squared? Yeah, the square root of the sine squared is just the sine. And here you're done. There's nothing left to do. But listen to my warning. You need to know when you're done, because these are circular. I can continue to manipulate this until I'm back to where I started. Watch. You don't need to write this down. Okay? So if I continue, I notice that 1 minus sine squared is the same thing as the cosine squared. If you look at your Pythagorean identities at the beginning, I said cosine squared plus sine squared equals 1. Well, if I subtract the sine squared to the right, that's 1 minus sine squared, isn't it? Look at your Pythagorean identities. Look at the first one I told you. And 1 minus the sine squared is equal to the cosine squared. So I could change those around. Well, what's the square root of the cosine squared? Cosine. So really what we have here is the cosine of theta over the sine of theta. And what is that? The cotangent, which is how we started. And now you're back at the beginning again. So you do need to know when you have to stop. Meaning, look at the problem, look at your answer. If you have a fraction under your radical, you got to get rid of that. If you have a fraction inside of a fraction, you need to move that. If you have a radical in your denominator, you need to remove that by rationalizing. Then once it's all of that stuff's typically done, then you're done. Otherwise, you're going to continue to just keep going. Okay? That's it.